We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
Hey stat students, let's go over lesson 4.4 and our learning targets. Learning target number 1, find and interpret conditional probabilities, right? Maybe your parents put on some conditions if you can go out, right? That's the word I want you to think about. Number 2, use conditional probability formula to calculate probabilities. So once we understand the conditions given to us, then we can apply that to probability. And then the last one, determine whether the two events are independent. That's the big one. Okay? All right, let's take a look at this. Learning target number 1. The probability that one event happens, given that another event is known to be, is called a conditional probability. Conditional let's do a pen here. Probability. The conditional probability that event B happens given A has happened is denoted by B Oops, that's a parentheses. The other one in the middle there is a vertical line. And this is read as given that, or you can use a word like kind of like under that condition. Under that, can't spell, that condition. Let me phrase it one other way. What's the probability given B, comma, given A? So the conditions are in B, then you have to look at A, okay? All right, let's take a look at that example we did previously. And that example we had was healthy, rich, or famous. Okay. One question on the census at school survey asked students if they would prefer to be happy, healthy, rich, or famous. Students may only choose one of these responses. The two-way table summarizes the responses of 218 high school students from the United States by gender. Suppose we choose a student at random from these 218 students. Define event A. So A, let's use a different color here. A is getting a female student, and B, event B is getting a student who prefers to be happy. Okay, so find the probability of happy given they are a female. Interpret this value in context. Okay. Guess you didn't really need the A and B, but you could if you needed it. Okay, what does the H stand for? That is happy. And the F means female. And we want the probability of this to happen. Okay, so given that they are happy and female, so given that they are female, so I'm going to locate that in blue here. How many total females do we have? We have 120. Right? We kind of talked about given, happy, given, female. So female is the biggest category there. And how many are happy there? That is 90. So we have 90 out of 120. Given that they are, remember what we talked about over here, given B, so B was, if you write the formula, if you did something like this, and it tells you event A is getting it comes second. Do you see that? Let me try to highlight that in orange. So this part was coming up second. So that's the formula. So given that they are a female student, so you're saying the second part first, the A part first, how many of those people are given that they are happy, okay? And if you just do the calculations, you'll get 0.75. What does that mean? Given that the randomly chosen person is female, I'm going to change my color to that light blue because we're only talking about not 218, but just that they're female. There is about a 75% chance she prefers to be what? Happy. So given that they're female and given that they are happy, right? Okay, let's look at the second one now. Given that the chosen person did not choose rich. Okay, so let me underline that. Let's use a different color. Let's use this neon green here. Not rich. Not rich. Okay. I'm going to call that my event A. What's the probability that the person is female? Okay, this one for female, I'm going to say this is event B. Okay, so I can write it as the probability B given what's the probability in those conditions that they are A. So this would be not rich and that they are female. So first look at all the people who are not rich. And I want to write this in a different way, a special way. Let's do it here in orange. Just as the notation. Let me write that. Notation. So probability that they are female given, okay, watch this one, rich. But not, we said not rich. And do you guys remember what that C stands for? The C there stands for the complement. Remember the idea that it's yes plus no equals 1. So if you subtract yes, it's no equals 1 minus the yes. That's the idea of the complement. Okay, so R to the C means not rich. Okay, so let's go ahead and look here. Let me erase all of this. Okay, what color is not rich? Green. Let me get the green color. Okay, basically if you look at rich and then look at everyone who is okay, here's rich, so I don't want that. I want this one, and this one, right? Not rich is being happy, it's yes, healthy, yes, famous. So I can add all of those up. So that would be 136 plus 33 plus 8, okay? Now let's go ahead and look at the females in those categories because that's my conditions. You have to be not rich. So that would be the 90, the 20, and the 0. Okay, 90, 20, and 0. This would give us 110 over 177, which is 0.814. And remember, if you multiply there, you will get 81.4%. There is an 84.1% chance, given that they are not rich, to get the probability of given a female. Okay, so that's a pretty high chance of getting someone. All right, let's go on to learning target number 2. Use conditional probability formula to calculate probabilities. So to find the conditional probability, we talked about A given B, use this formula. So start over here. A given B is the probability of A and B over the probability of B let me try to highlight this one. Show this into better. I'm going to do a play on the letters so you kind of remember it, okay? And we're going to do this one over here, and the probability of A intersection B over probability of B is the probability of both events occur over the probability that the given event occurs. Okay, so this is a conditional probability to figure out in our formulas. All right, let's look at example number 2, more dogs and cats. In one large city, 40% of households own a dog. Okay, I'm going to underline that and make sure we understand. 40% owning dogs is this blue circle. 22 plus 18 gives me the 40. Okay, why did we separate them? Well, let's keep reading. 32% own a cat. So in orange, there is my cat. And 18% own both. So that number is in there. So 18 plus 14 gives me the 32%. 22% only own a dog. 14% only own a cat. And if you add those all up and you subtract it from 1, you will get 46 that don't own a dog or a cat. Suppose we randomly select a household and record which type of pet is owned by the household. Here's the Venn diagram showing the relevant probabilities. I'm missing what we're supposed to find in here. Let me just write it out. What's the probability that a randomly selected resident owns a cat, also owns a dog? Okay. So let's go ahead and color code this again. Owns a cat. This is my A. Oops, that looks like a star. A. And owns a dog is B. Or you know, you can choose to use the variables. So you can also use cat and D for dog. Okay, so you can have something like this. What's the probability that, given that they own a cat so that's the first condition, and then given the second condition, they own a dog. So first, those who own cats, and then those, given that you're only looking at that little category, those who own cats, who of those own dogs? So our formula, or we can simplify that to just P D for dog, given they own a cat. Okay, and then our formula from above is this one. Remember, this one over here means intersection, and that's why I kind of drew that pink there. And this one over here, I want you to kind of think of that as kind of play on words, kind of like an and, or I guess you can use the and as well. Okay. All right. So our formula that we're going to use is probability of the intersection of dogs and cats over the probability that it is just cat. Okay. So again, this right here means intersection. Guess I should just a different color. This means their intersection from that N. So where is the intersection of my circle? That is everything here. So that would be point 18. Okay, what's the probability that they're a cat? Okay, remember cats, if you read it, is 32%. But in our Venn diagram, that is the whole orange circle. So I like to draw it like this, right? That's the 18 plus the 14. You add those two together, you're going to get 32%. Okay? So you can put 18 plus 14 there. Don't be silly, you can't cancel those because they're not factors. It's an added. There's an addition there. So that would be 18 divided by 0.32. And if you did that, you would get 0.5625. There is a 56.25% chance that you will find a resident who owns a cat also owns a dog. That's an example of conditional probability. All right, let's go on to the last one here. Learning target number 3 here, we're trying to figure out how do we determine if two events are independent. So example 3a, I want you to think about a coin. When you flip a coin, they call this one is heads and one is tails. And our coins normally don't have something that has like a monkey tail. It just has, I don't know. If I think of a penny, I don't know, the Lincoln Memorial or something like that, right? And if you see a head, you actually see a profile of someone's head. So let's just think about coins for a second. Suppose, number 1, you toss a fair coin twice. Fair just means it's equal chance of getting heads or tails. And you're doing this twice. So you're saying the first time you're flipping a coin and you want your probabilities, you want to get a head. And B, the second toss is you want it to also be a head. So basically, what's the probability of getting 2 heads? Well, you know that the probability of just flipping the head on the first one is 1/2. Just a reminder, these are the total 2 outcomes. That's a head or tail, and then of course we just want a head. Okay, and for probability of event B, okay, pretend now you just picked up the coin, you're going to flip it again, and it's only 1/2. It's still going to be 1 out of 2. It hasn't changed. Okay, so what's the probability of event B given event A? So what's the probability of flipping a coin a head a second time given that the first one was a head? It's the conditional probability that second toss is given that the first head was a head. The coin has no memory. So the probability given that you want a head, given that you've already flipped a head, is still 1/2. the probability hasn't changed. So what's number 4? What's the probability of event B, meaning on your second toss it is ahead, given, okay, remember this one, this is not A. Let's write that. This means not A. Why? Remember, this means the C is the complement. I always like to think of it as yes plus no equals 1. Okay? So it's the conditional probability that the second toss is ahead, given that the first toss was not ahead, which means it was a tails. Getting a tail on the first toss does not change the probability of getting ahead on the second toss. So the probability of event B, which is getting ahead on the second toss, given that the not A occurred, so you didn't get ahead on the first one, you got a tails, is still, what do you think it is? 1/2. It hasn't changed. In this case, B given A is when it's equal to the probability of B given not A, basically means it's equal to the probability of B. They are the same. Let me write that. Pick a different color here. Basically means they are equal. Knowing whether or not the first toss was ahead does not change the probability that the second toss is ahead. We say that A and B are, we call this independent events. Okay. A and B are independent events. If knowing whether or not one event has occurred does not change the probability that the other event will happen. In other words, events A and B are independent if probability of given A given B is equal to the probability of A given not B equals the probability of A or the other vice versa. That's the second format. So basically, you're kind of saying it both ways. It could be A then B or B then A. Kind of confusing, but basically you just want to know, summarize it, if you want to know if the probabilities are equal. If they're equal, then they are independent. Okay? Let's go ahead and do an example, and this should make more sense. Example 3b. Is there a relationship between gender and allergies? Remember, this problem is checking for independence. Data on gender and allergies were obtained from a random sample of 227 students who responded to an online survey at the Census at School website. The data are summarized in the two-way table shown below. Suppose we choose one of the students in the sample at random. Are the events female and allergies independent? Justify your answer. Okay, so what do we want here? I'll just use pink for female. This is event A, and allergies is event B. So what we're trying to find here is the probability that B, I'm trying to use this color-coded to help you, given A, oh, that's supposed to be pink. Okay, and that's the first one. The second one is testing the other way around. Probability that B occurs. Okay, pay attention. And remember, this one is not given not A. Okay, so I'm going to have to basically do two separate problems. And divide this, okay? Okay, so what does this really mean? We basically want the probability of allergies Okay, what is event A? That is female. Okay, so I like to go on to the second one first, because that is kind of like my denominator. If you can kind of think about turning that light blue and the pink sideways, like that's like a sideways fraction. Like if I wrote 2/3, that's like 2/3, 2 on top of 3. So it's like kind of like allergies on top of females. Does that make sense? So my females is my total. So if you look at how many females are there total, that would be 130. Okay? And now, given that they are females, here's my condition. I'm not looking at both males and females. I'm looking at just females. How many of those females have allergies? That would be 50. Okay? 50 out of 130 gives me, put in your calculator, 0.385. Okay, so right now basically what we're doing is we're testing for independence. Okay, let's make sense of this second problem we have to do. We have to do kind of like these two of them to verify the formula. Basically, I want the probability that someone, given they have allergies, so probability of allergies, okay, given, okay, what does not female mean? Not female, what's the other gender there? That means male, okay? Basically, I want male. And I'm going to erase everything over here. Okay, so let's look at this. Remember, I'm going to look at the denominator, or the right side first. Right side first. Okay, let's look at all of the males. The total for males is what? 97. And the probability, okay, here's a conditional probability. I'm looking at just the males. How many of those males have allergies? That would be what? 34. Okay, so if you put it in there and you do a decimal, you'll get 0.351. Okay, here's the question about independence. Are they equal? The answer is no. All right, let's write let's justify our answer now. Are the events independent? Because these probabilities are what? Equal or not equal? Not equal. The events female and allergies are not independent. Knowing that the student is female, increases, I'll tell you why I got increases in a second, the probability that the student has allergies. Okay, now how did I get increased? Well, if you compare the two numbers above in white here, 0.385, 38.5%, and 35.1%, which one's higher? This number is higher. Well, who did that come from? That came from females. Females, because you are female, based on the study, right, we're taking, that's what kind of like statistics and probability is, right? You're taking a snapshot of just our sample of 227 students. This is telling us that based on those students, if you are female, then you have a higher chance of having allergies. Okay? All right. Go on to the next example, number 4. You try it. It's reviewing everything, and then press play when you want to see the answers. All right. I decided to do this step by step, so this might be a little bit better pace for students. So students at the University of New Hampshire received 10,000 course grades in a recent semester. So pretend like, kind of like you as a high school student, you take 6 classes, maybe at university take 5 classes. So that means, you're looking at maybe 2,000 students. The two-way table breaks down these grades by which school of the university. So if you guys didn't know, at a university, say Cal State Fullerton, there's a bunch of schools inside of it. So think of it kind of like 6 mini high schools. And the schools are broken up into different things. Here they are. The schools are liberal arts, engineering, physical science, EPS, and health and human services. So kind of 3. Let's just number them. 1, 2, 3. Okay. Choose a University of New Hampshire course grade at random. Given the 2 events, E means that the grade comes from an EPS course, a engineering physical science course, and L means the grade is lower than a B. Okay. So here they are. Here's my two-way table. And sometimes with two-way tables, it's kind of helpful if you kind of add them up. That's how I find helpful, but you can do that later too. So the first question is find the probability given L, the grade is lower than a B, given that the grade comes from an EPS course. Okay, so let's write it out in words. Sometimes that's just super helpful, right? Probability that it is an L, and L means a lower grade than a B, given E. E is a grade from the EPS course. So we'll just write EPS because that's the name of the school that's coming from. Okay, so let's just take a look at what we see here. Okay, so again, the question is which one do we use, the light blue or the pink? Remember, it's kind of like, I don't know if I can change this, but this might be helpful. Lower grade than B. Okay, pay attention. Given the condition is from EPS. Okay, so let's go ahead and find that EPS. EPS is the engineering physical science, so right here. Okay, given from this school, okay, that is, if you add all of those up, you will get 360, no, not that number. 368 plus 432 plus 800 gives me 1,600, okay? 1,600. Okay, based off of that condition, right? I'm not looking at the whole university. I'm looking at just one particular small school, the engineering physical sciences. Which one of these has a lower than a B? Well, that's here, which represents this number, 800. So what's the probability? Well, that's just 1/2, and that's just 50%. Or 50%. Let's write a, it tells us, interpret this probability in context. Given that a grade comes from where? Where do we look at? The whole university? No, just comes from a EPS course. There is a 50% chance that the grade is lower than a B. Okay, so you look at just the EPSs, then there's a high, half the grades are going to be lower than a B. Well, I don't know. Engineering sounds really complicated. Lots of math, right? Is everyone doing super well in those classes? Maybe not. Okay. Let's do, are events L and E independent? Okay, when you see the word, are they asking this question about independent, you're going to have to break it up into 2 kind of problems, okay? And basically what you need to do, which we already did, is if you go back up, they want, remember the first one, I'm just going to highlight it so you can see this right there. So essentially you're doing one that says kind of like a yes. Whoops. Whoa. This is like yes over here, and this one's the no. Okay, so what do I mean by that? Up here it says the probability of L, a lower grade, given the EPS, right? And then over here, what I mean by no, N-O, sorry, poor spelling. What's the probability that they have a lower grade given not E? That's what I mean by no. Okay, so let's go ahead and do this. Now, you already did this one, right? Does this make sense? You already did the probability of a lower grade given EPS. So you can just, look at this. Boom. Magic. We already did it. Boom. It's already 0.50. Okay. All right, let's do this one now. Okay. What does this all mean? Let's write it down in words. What's the probability that they have a lower grade than a B? And I'm using all that long words because you look at our table, that's one of the things there. Okay, given what? Not EPS. Not EPS. Okay. Now, you could do two things here. You can just take the complement of that, or you can say, okay, every course that's not in the EPS. Okay? So what is that? Let's go back up here. Let's erase all this. Okay, which one is not EPS? Well, you can do the liberal arts plus the human health services. Let's add that up really quickly. 2142 plus 1890 plus 2268 gives me 6300. Oh, let me write in pink. I'm trying to stay consistent here. 6300. And 882 plus 630 plus 588, that gives me 2100. Okay? So that is my total. So let's write that down. 6300 plus 2100. Okay? All right, now let's go ahead and locate given the conditions are the nots, who had a lower grade than a B. Okay, so given those two conditions, just the pink and the orange boxes, which ones had a lower than a B? Well, that's 2268, 588. 2268. So given that's not EPS, plus 588. Okay, then we just add those up and put into your calculator. You will get 2856 over 8400, which is 0.34. Okay, questions. Are they equal or not equal? And they are not equal. Because the probabilities are not equal. The events EPS and lower than a B grade are what? Independent or not independent? Not independent. So if they have the same numbers, then they are independent. If they're different numbers, then they're not. Okay? What else can we write? It just tells us to justify our answers. knowing that a grade, so we randomly pick a student and they're in the, it comes from the EPS course. What happens? Remember, the left side was yes, and this side was no. Which one has a higher number? The one we want, right? The left side. That means it's coming from here. Yes, it's coming from there. Then the number is what? Bigger, so it's an increase. So if you pick that one, then you have an increase. But here's the weird part. It increases the probability of what? The second part. Given that you go to EPS, there's an increase in a what? L. What does L stand for? L comes from a lower grade than a B. So it sounds like a harder place to go. It is lower than a B. Okay? Of course. All right, let's summarize what we learned. Learning target number 1, find and interpret conditional probabilities. Number 2, use the conditional probability formula to calculate probabilities. And then number 3, determine whether two events are independent. If the numbers are the same, then they're independent. If not, then they're not independent. And that's lesson 4.4. See you guys.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today. We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today. Listen up and behave. We doing math today. We doing math today.